Welcome all to the Mosfet gate lecture series. So in this lecture we are going to learn one of the most beautiful question. Anyway, we are learning the concept through problems only. Before starting the questions or learning the concept, if you are understanding whatever the content that I am delivering here, don't forget to click that like button and also share it with all your friends. So let us start the question. See here, the given question is one n-channel MOSFET is given and it is clearly shown in the figure. The value of VB is given as 2 voltage and the value of Kn they have defined. Kn means mu n Cox omega by L equal to 40 microampere per whole square. Threshold voltage equal to 1 volt, whereas what is the value of dVb by dId? So first, what is this VB? If you observe the diagram clearly, it will be clearly indicated that VB is nothing but VD, yes or no? Because this voltage is injected at a drain terminal. Sir, how did you figure it out? How do you know whether it is a drain terminal or source terminal? We know always the direction of the current will be given only across the source terminal. So opposite is going to be drain only, and we will be having one more terminal, that is gate. Next, remember one more thing. Whenever they are asking you to identify the ratio between voltage, current or current to voltage, it will always be solved with the help of drain to source current. Always remember, even if you observe the previous questions at all, whenever we are bringing the relation between voltage and current, that will be done from the current equation only, because in the current equation only we are having the relation between current and voltage. Okay sir, I understood that we have to bring the relation between voltage and current, but which current I can take here? Which current means there are two current. If MOSFET is operated in the linear region, we have to consider one equation. If the MOSFET is operated in the saturation region, then we have to consider one more current. Which current we can consider here? For that, we have to identify the region of operation. Now, if you observe the diagram carefully, I have been told this many times. Whenever your gate and drain terminal are shorted, whenever they are shorted, then directly you can give the conclusion that your MOSFET is being operated in saturation region. Now, if you observe the diagram clearly, it clearly represented that the value of the terminal of the gate is directly shorted with a drain. Yes sir. So the region of operation is saturation. So when your MOSFET is being operated in the saturation region, what is the expression for the current? How will you write down the current expression? So let me write down the current expression first. Okay sir. So we can write the value of drain current ID is equal to mu n Cox omega by L. Of course there is one more factor 2 in bracket, it will become VGS minus VT whole power 2. Sir, I wrote the equation, but what I told you, we have to bring the relation between voltage and current, VB and ID. Whereas here from the diagram it is clearly visible that the value of VB is nothing but VD. Yes sir. Now how can I write this, how can I bring this VD into this current expression? For that we have to think smartly. If you observe this MOSFET diagram clearly, the value of source voltage Vs equal to 0. Sir, why it is 0? Why? Because source terminal is connected with the ground, whereas the value of ground potential is always equal to 0. So I can say the value of Vs equal to 0. And value of gate, value of drain voltage, both are same. Why? Because they are shorted together. So I can say drain terminal and gate terminal all are same only, they both having the same voltage. Now let us write the relation between VDS and VGS. VDS can be written as VD minus VS. Since the value of VS is 0, so I can write this one is VD. We all know VD can also be written as VG because they both are equal in from the given diagram we have been observed that. Similarly, if you are trying to write the expression for VGS, this can be written as VG minus Vs. Since the value of Vs equal to 0, so once again this can be written as Vg only. From this, if you observe both RHS are equal, so I can say the value of VDS and the value of VGS both are equal. So in place of VGS, and one more thing you have to understand, see there, this VG is nothing but VD, this VD is nothing but VB, yes or no? Similarly, VG is nothing but VD, VD is nothing but VB. So the conclusion is, in place of VGS, directly I can replace it by VB, because we need VB only. We have to bring the relation between ID and VB. Now it's time to bring the relation between ID and VB. What we need to do, we have to differentiate the current with respect to voltage. After that, I have to take the reciprocal, because here the relation is VB by ID, whereas I am having ID equal to something. So let me bring the relation slowly. What I am going to do is, I am going to differentiate this current with respect to voltage VB, such that what you will be getting, mu n C ox upon 2 this omega by L. Again, these all parameters are constant. When I am differentiating this function with respect to VB, what will happen? See, in place of VGS, we are having VB now. So this can be actually written as VB minus VT whole square. This expression can be actually written as VB minus VT whole square. If I will differentiate it, it will become 2 times of VB minus VT into internal differentiation will give you 1. That is the complete derivation. But here I have to know the relation between dV by dID. So for that, I am going to take the reciprocal for this expression, such that this will become dVB by dID equal to, what will happen if I will take the reciprocal? See that this 2 anyway will get cancelled out. If I will take the reciprocal, then this L will become numerator. So I can write like this. 1 minute. So how I have to write this expression is, L will lies in the numerator, rest of all people will goes to the denominator, mu n C ox omega, in bracket I can write VB minus VT. Or you can also write in the alternative way, instead of bringing this L to the numerator, you can also keep like this, omega by L. Directly you can substitute all the parameters. Now do you know all the values in this expression? Yes sir, we know all the values. 1 upon, if you observe, mu n C ox into omega by L, it's already clearly given in the question. How much it is? It is equal to 40 microampere per whole square. Micro means 10 power minus 6. So if I will substitute that value, the whole value can be replaced by 40 into 10 power minus 6 into, in bracket, VB minus VT. The value of VB is given as 2, VT value is given as 1. So 2 minus 1 will become 1. Further, if I will proceed further, bring this 10 power minus 6 to the numerator, it will become 10 power plus 6 upon 40. I hope you all understood. See, from this, if I will reduce 1 by 40, what is the value of 1 by 4? 1 by 4 will be 0.25. So 1 by 40 will become 0.025 into 10 power 6. Or I can also write this one further. How can I write this? We got 0.025 into 10 power plus 6. So this can be further written as, I am going to break this 10 power 6 into 2 part, 10 power 3 into 10 power 3. Pass 1 10 power 3 inside. It means 0.025 will going to be multiplied by 1000, such that this will become 25. Another 10 power 3 can be written as kilo, and voltage by current, what is the unit? V by I means that is nothing but resistor. So directly I can write this is nothing but resistor. Of course, I can also say this is called drain resistor, because basically drain resistor can be defined as D, 1 minute. Drain resistor means according to Ohm's law, this can be defined as dVds by dID only. If you observe this expression, already we got the relation. VDS is nothing but VB only from the given question. So here we are also doing the same only. In place of VB, if I will substitute dVds, then you will get the same expression. This is nothing but RD only. Indirectly, we were requested to calculate the value of RD. So finally, the value of RD will become 25 kilo ohm. So don't forget, suppose in any examination, what they will do is, they will be giving you all the relation, like they will give you the value of mu n, C ox, omega by L, and the value of VDS or VGS, VT, all the data they will give you. You will be requested to calculate the value of RD. If you want to calculate the value of RD, RD is nothing but the ratio between dVds by dID. If you do remember this expression, directly you can calculate the value of RD. Okay, so don't forget this. This is most important. You can also observe few of the questions already asked in your examination. I hope you all understood what are the things that I have delivered in this lecture. Remaining things we will see in the next class. Thank you all.